Pranav has read it in the morning, so everybody knows about it. As I was introduced, I am from Manik Engineers, and we have been manufacturing walls controls for more than 47 years in India. So when we talk about refrigeration, it has got multiple applications and it can be used everywhere. In fact, now today's our life, directly or indirectly, is linked to refrigeration. I think everybody eats the chips, potatoes. So potatoes we get 24 hours, 365 days only because of the refrigeration. Earlier they used to be there for 3 or 4 months. Now you get potato everywhere in India. It is because of the cold storage is there, cold chain section is there, and it is available everywhere. Similarly, whether those are the frozen products, the ice creams, delicacies, the milk we take every day. I remember when I was young, my grandfather used to go in the morning and stand in queue to get the milk. And there was a card, so you get limited milk. Now you get 24 hours milk in India. So this is all because of the possible only because of the refrigeration. And then your medicines, India is one of the largest manufacturer of pharmaceutical products and being the lowest price. If you buy a Crocin in Dubai, your eyes will pop out. Simple Crocin which we buy for 5 or 10 rupees, you go to Dubai, they will talk about 20 dirhams. And it comes from India. So this is what has been happened because of the refrigeration in India, and India has done great in refrigeration. What I am showing you some of the slides which will give you bit information about what are the products, temperature ranges in which refrigeration, warehousing, storage works. But other than that, we also have a lot of refrigeration applications into pharmaceutical industry, into chemical industry, into construction industry. Construction industry, when you see these big dams, roads are built, there are a lot of ice is mixed into the concrete to change the settling times, the transportation times. And everywhere, directly, indirectly, this refrigeration comes in your life nowadays. Apples you buy, the American apples come to you because of the refrigeration. So this sustainability and energy efficiency is what's supposed to be talked about. A definition of sustainability is ability to maintain or support a process over the time. But it also means that your plans, projects which you have put up, it should run for longer time, longer days. So in Indian scenario, the plant built by the father, son should able to run it. That is the true sustainability. That is what we have been doing in India. So to have such kind of plants, we need to understand what should be done to get the best out of best and at the very affordable cost. I'm not saying cheap, because cheap means sometimes poor quality, lower quality. That should not happen. But what we should have is the best at the very moderate cost. In any refrigeration plant, the most important decision is about refrigerant. And we heard a lot of people talking about, those A refrigerant, B refrigerant, synthetics ones coming in, going out, and then every 20 years we have a different refrigerant. So what happens is to my plant? So I have to change the plant, or I have to change certain components, I have to change the oil, I have to open the plant, clean it and put it on another oil, another refrigerant, because my R404A is gone and now I have to bring in the 448. So like those things we need to think about it. And then comes the energy efficiency. My refrigerant has to have a most energy efficient thing. Because if I am processing and freezing a product, I must freeze at the lowest possible cost. If I am storing the product for 4 months, 5 months, my potato is being stored for 6 months, it must be at the lowest possible cost. And same thing, ease of availability. One is the ease of availability of the refrigerant. Secondly, ease of the availability of the equipments which are made. And of course, as I said, cost. Cost has to be low. I'm not saying cheap, because in India, cheap and low are different. And we will talk about it as we process. So when we talk about energy efficiency, sustainability, the electrical energy is the maximum consumed into different types of industry, whether it's dairy, ice cream, food freezing industry, cold storage. You need a lot of energy, or your major contribution of your electrical energy goes into the refrigerant. So you must select appropriate and proper refrigerant. So what are the criteria to select the refrigerant? One is the latent heat. Latent heat is the heat in which your heat, when a liquid is being transferred from to gas, that is where you generate maximum heat transfer into a refrigeration plant. So if you compare to that, you have to find out which refrigerant gives you maximum latent heat and which refrigerant gives you less power consumption. That is what where we talk about COP. COP is a coefficient of performance, means your refrigerant capacity versus the electrical power requirement. If you see here in all the applications, ammonia gives you the best COP. Now talk about latent heat. Water is the only refrigerant available which has got latent heat better than ammonia. So, but unfortunately still today, water-based refrigeration systems are not yet available. I was told that they are under development and some of the companies in Europe will come out in 2026 in Chino exhibition, but they are not available. Technology is not available. So out, then you go, the ammonia becomes the best. So you have to select those latent heat and the COP of refrigerant which makes your plant most energy efficient, or what we call in India typically when we are buying a car, we ask question, kitna deti hai? Without looking up the average, we never buy a car. Very few people will buy a car without looking at the average of the car. Same thing happens about the life of the refrigerants, availability, and if you see those refrigerants come in and go. They came R11, R12, R22, R4048. Now everybody is going and they are bringing in new. As I told, then you have to change the plant, you have to change the machinery. Ammonia is the only refrigerant which has been there for more than 100 years and it's still going to be there. It is only because the technology and it is the most natural refrigerant. Then so many people talk about GWP, OWP, the HCFCs, HFOs, HFCs, HCs, so many names come up. But if you look at this, the ammonia has got 0 OWP and less than 1 GWP. No other refrigerant beats ammonia. So this is having a refrigerant which has got the 0 natural effects on the nature, 0 life into the atmosphere. That is very important. Not many people talk about life of the refrigerant into the atmosphere. Like if it is released to the atmosphere, what happens is with that? Normally ammonia will break into nitrogen, which is already there in your atmosphere. And then ammonia does not exist. So those all things you have to do. Now HFOs have come. People talk about it, low GWP refrigerants, they must be implemented. But you look at the US, there are so many issues are going, and I think Mohit sir also told us about the issues we are having with the HFOs and cancers and other things coming and harming the human bodies. As I read correctly, there are some cases going on in the US about mixing of these HFOs into water and then harming the human body. So we have to find out a refrigerant which is sustainable, which we are going to get it for next 20, 25 years, 30 years, which is not going to damage our nature, which is going to, our next generation is going to get the same nature, and it is, we are proudly going to say that we have not damaged your nature by using synthetic polluting refrigerants. These things happen everywhere in the world. Sometimes we are slow to response, sometimes we are not aggressive into it, or we have an attitude of chalta hai. Look at this, the one which the regulation passed by the California government. They are banning HFC refrigerants. They are not allowing them, like R4048 or R507 will not be allowed from 1st January 25. The GWPs will in 2023 the 1500 is going to be GWP limit, so refrigerants like 407A or 407C are going to be phased out. In 2033, GWP limit will be going down to 750. So resulting R134A being down. So R11 was there, it was replaced by R22, it was replaced by R134A, and now it is also going. So normally we Indians follow the white skin. We have a very affinity to white skin, maybe 150 years Raj was there. But we have this affinity, so once Americans are doing it, we will also do it. But we might do it little later, but it is going out. So what we have to see is ammonia. Why it is ammonia? Well, it is one of the oldest refrigerant. It has been there, it is available, it is going to be available in future. Nowadays, a lot of people come with the green ammonia technology also. There is no difference between the ammonia and the green ammonia. Only manufacturing technology is different and the cost is more. Remember, ammonia is not specially manufactured or tried. It is exists in nature, and also it is part of the fertilizer industry. Only 1% of ammonia produced goes into refrigeration. It is less expensive, the cheapest refrigerant available. So one refrigerant common from minus 45 degrees centigrade to plus 15 degree applications. You don't need to have R134A for air conditioning, R04048, then R404A, we talk about temperature glide. All these things are not required. I talked about OWP, GWP. It is thermodynamically most stable refrigerant. It does not have any effects on thermodynamics of a refrigerant when there is a different temperatures operating at different conditions. It's not miscible with the oil, ammonia. So separating of the oil is very easy. Oil is not required for refrigeration. Oil is required only for the compressor. So what we have to do is keep our oil only in compressor. We don't want it into evaporator, don't want it in the condenser, or we don't want it into the LP vessels or pump vessels. So ammonia system components are smaller than other HCFC or HFC systems when you are comparing for the same temperature and the same refrigeration capacity. Because this myth is always there, people talk about I have smaller, small. If you have same refrigeration kilowatt heat rejection, the latent heat of ammonia is highest. So naturally, to get the same heat transfer, you need to pump more refrigerant. To pump more refrigerant, you have to use bigger size of the pipes. If you compromise and use the smaller capacity of the equipment, then only you can have a smaller capacity of the sizes. Refrigerant get available everywhere in India. There is a lot of fertilizer plants who produce this ammonia, and then there are bottlers, packers who give you things. And like I said, this is the father has built the plant and son is going to run it. So you don't need to change refrigerant, invest more and more just because there is a change in the refrigerant or refrigerant is banned. Typically, ammonia is R404 or 407 is 10 times costlier than the ammonia. So when you are having, if your latent heat of ammonia is high, the latent heat of R404 is less, it means you are going to pump more synthetic refrigerant, you need more quantity of refrigerant. To get the similar effect, you need less quantity of ammonia. So cheap, cost is low, and also the less quantity of the ammonia. These are some of the actual case study examples I am just presenting with you. When you are using ammonia as a refrigerant for say minus 3 degree centigrade, most of the freon plants are at 52 degree condensing because they are air cooled, ammonia is water cooled. You can see what are the power savings achieved into this kind of systems. Or when you go for a blast freezer, somebody was talking about a blast freezer here. There's a huge energy consumption difference between plant with ammonia and plant with R404A. Then there are some people talk about, even during lunch I was talking to the people, that ammonia is flammable, ammonia is hazardous. Ammonia is not flammable. Ammonia can ignite only around 650 degrees centigrade. So when your ambient reaches 650 degrees centigrade, then your everything is going to be burned out. You are not going to survive there. Then ammonia is classified B2L by ASHRAE. So naturally it is not flammable. Yes, it is toxic refrigerant, but then there are so many things in our life where toxicity is there and we live with it. So if we use proper leak detection systems, we use proper products, we use the correct items, then definitely we can reduce the harmfulness effect of the ammonia. So we can very easily see that ammonia is the most efficient refrigerant when you are looking for sustainability. You're talking about 20 years, like Ramdas sir said, in Unilever, they are more worried about sustainability. So they bought the plant with R404A, and after 10 years they want to change it to ammonia. Right, sir? So that should not happen. If you buy the plant with ammonia, you don't have to change. Unilever Sindar plant has been running with ammonia for so many years. So these things is very important. Plant life cycle, plant equipment cost, and the running of the plant has to be fully considered. Second question, like particularly when this we had a very wonderful discussion about the heat pumps. People were talking about reducing the cost, the availability of the components. The imported components are there, components coming from Europe. Now there is a problem with the Suez Canal, so material coming from Europe takes a lot of time, and then again there are political issues around the world. What happens is the war breaks out. If there is a war between the Russia and Ukraine escalates, Europe gets involved into the war. All these things definitely going to affect your plant. Your sustainability is going to get affected. You are definitely going to get affected in your operation of the plant. And many times when you are having, for example, a seafood processing plant or a vegetable freezing plant, your job is not to put the refrigeration plant. Your job as an investor is to run the freezing. You have to get the raw material, freeze it and sell. Your main job is to sell, like Piramal is there. Their job is to make the chemicals, pharmaceuticals. Their job is not to run the refrigeration plant. But they can't stop their production because of the failure or non-availability of the refrigeration components. So because the cost of the pharmaceutical produce is much higher than the cost of the refrigeration plant. In one batch, they can afford to buy one refrigeration plant separately. That's the typical way of this industry works. So what we should for sustainability, we should look for the availability of the cost, components, materials, equipments, and of course the serviceability. We should have service people available in India. We should not be dependent on European people coming or American people giving us service. So what we need to look is actually look for the Make in India. That's what our Honorable Prime Minister is talking about, Make in India. Look for the Make in India components, look in India, Make in India products. And I'm very proud to tell you that ammonia refrigeration industry is the only industry in India, when it's talk about HVACR, is fully indigenized. It's everything made in India is available. You look for, sir, you want to make the heat pumps, you go make with the ammonia, you get high pressure now heat pumps, compressors are available in India. There are people manufacturing HP compressors. Already heat pumps of ammonia with 70-80 degrees are available in the market. You use HP compressors, you can go for maybe 100 degrees water temperature with in heat pumps. Options are available, made in India options are available. The advantage is that these components are made in India, the parts are made in India. You can very easily use it, replace it, services, maintain it. You don't have to depend on getting it from Europe or China, and in case of any political issues, instabilities or variations. Recently, there is a lot of issue happening with the euro price going up. So you are quoted X price, by the time your equipment arrives or you make payment, the euro price gone up. Who is going to pay for the difference? This does not happen when you buy the Made in India products. So consider Made in India products because you want the sustainability. The lesser cost of your plant, lesser and age availability of the technology, your ROI on the plant investment is going to be better. You have a better investment, you have a better product, you have an efficient, easy to maintain product, definitely it is going to be more sustainable. That is what it is. Finally, if I buy a car, it should work for 10 years. I don't have to replace it every 2 years. That's our Indian mentality. We are not reached to the use and throw technology yet. Then when we are buying these Made in India components, another very important thing is that now the Made in India components are available as an international quality, international standards. So look for the certified products. Do not buy uncertified products. There has been tendency that chalta hai attitude is there in India, so people sell substandard products in India. A typical company sells better product in Europe or rest of the world, but they sell substandard products in India. So you make sure that what you are buying is a certified quality product available. And I'm just giving you an example, ammonia pumps. 20 years back we used to import pumps from Europe, and that time we used to pay 7.5 lakh rupees for a ammonia pump. Today ammonia pump made in India with CE and UL certification is available at 1.25 lakhs, which gives you the same performance. And available in 15 days. I don't have to wait 6 weeks or 8 weeks for the delivery. So always consider this kind of products to use. That will make your plant sustainable, and it will have a lower capex cost, and you will have a better OPEX cost because maintenance cost is less. Basically the product itself is less. See, when you buy, I'll tell you, the first time the Mercedes was bought by my partner, and it is 2005, 2006. In the 1 year, our suspensions failed. So we went to the Mercedes showroom. They said you have to replace the tires and you have to replace the shock absorbers. Suspensions you have to replace. That was costing around 2.5 lakh rupees at the time. I said, but it is just in a 1 year old car. How much our car is, not designed for Indian roads? That was the answer given by the Mercedes people. So they were saying India should improve the roads to run the Mercedes. We don't want to buy such cars. We want to buy a Maruti which works on our, or Toyota even for that matter, or Hyundai, which actually work in our roads. A lot of potholes are there even we are coming to this hotel. The road is full with the pots, so car must work. So these things we must look when we are buying a plant, we are putting up the plant. Because I am buying something cheap, something coming from China, and then I'm putting it into my plant, and then it blasts. Sorry. It happens like this to the many products also in India, compressor blast. So look for what you are buying, make sure you have the correct products are bought, and I think I'm not able to see my friend here. Is that Mehta sir? India government is very active. Like in the morning he asked a question about the standards and everything. Indian government has gone ahead of it. They have come up with the QCO. How many of you know about QCO? Yes sir, Makaran sir. So please explain them what is QCO.
It's an order,
yes.
Quality control order.
Yeah, it is called Quality Control Ordinance. It is released by the government of India. And to import products, particularly from China, all your products must have ISI marking. From 1st August 2024, you cannot sell substandard products in India. There has been mentality of many people, companies, importers to buy cheap Chinese material, sell it to India. You see, many of you have learned or seen the news, mobile phone blasted when they were in the charger. The electrical cables getting immediately on their own, sparking and burning. All this has stopped because of the QCO implemented by Government of India. Okay, it's government process, so sometimes it takes slow, some products don't get added faster, but government is doing it. So please somebody convey to my friend that government is doing something. And look for the certification of the products when you are buying. There are international certifications, C, P, D. Now we also have ISI certification for the products. As I told you, it is compulsory for the people bringing in products from China to have this ISI. It will very soon be compulsory for the people bringing in the European products also. They have to get registered and certified in India. There is a UL certification, there is NB marking available. Make sure that you buy products with the quality. And I'll assure you, as in ammonia industry for last more than 30 years, Indian ammonia industry is geared up for this challenge. We have Make in India products. We have all these certified products manufacturers in India. Follow the standards, follow the technology available, and you will get a sustainable plant. Latest trend in India is to go for a stainless steel. Particularly in ammonia refrigeration in last few years, most of the companies are switching over to stainless steel pipes, stainless steel walls, suggested automation. It is mainly because the rusting issues, the hygiene issues when happens inside the plant room or a process hall. If my MS pipe gets corroded, my plant does not get cleared for the hygiene issues. So I need to go for a stainless steel. So look for it. There are a lot of good products are available. When you talk about when you are having safety walls in your plant, make sure that you have a safety release systems in place. So you get the safety ammonia is released outside to the area. Follow the standards for that. There are ammonia detection systems are available. So you provide the systems so that your plant becomes more safe and of course makes it sustainable. This is a very typical calculation I just put up for your display. Many people talk about it. How much is the percentage of ammonia leak is allowed into my plant or my area? So this one shows you the different refrigerants. What is the percentage by volume is allowed, and then how much it is. If you see a typical machine room of 20 meter by 12 meter by 6 meter height, you can have 7% ammonia into that. So these things you need to follow. As I said, you put up the systems there, working systems, make sure that they are available and running, and you have those plans. So what we can say is that follow the standards and guidelines. As I told you, our government of India has published and has already officially adopted AR standard 17773 is there. You can download it free of cost from BIS website. So use that standard for your plant design, your plant modification, upgradations. Do not compromise on the material. Do not use substandard material. Do not use material only made for India category. Go make sure that you follow the standard materials as per the rating specification in the standard. Pressure vessels, I'm just giving you example, must be made with SA 516 grade 70. Do not use IS 2062. IS 2062 is basically a structural material. It is not made for the pressure vessels. Don't use it. Use mostly the seamless pipes. Don't go for the ERW pipes. Use 2W two-stage systems below -15 degrees centigrade. These are some of the tips you can consider to make your plant more energy efficient. Use proper guideline books, standard books for your plant operation maintenance. These books are available from Association of Ammonia Refrigeration. You can look at their website. There is a standard book, there is a plant operation maintenance book, cold storage design book. Everything is available. So have a look at it, use it. And then most importantly, when it comes to the plant operation maintenance, generate your own SOPs, standard operating procedures. Make sure it is verified by the experts. Get it correctly done by the by experts, consultants, and then keep following those SOPs. Do not change SOPs. Make sure that all equipments are in working condition. Do not bypass equipments. I have seen it has happened. After certain times there was some leakage, so that intercooler is bypassed in the system. And then how do your compressor will work? So it is inefficient operation of the compressor. You are not getting the desired temperature. So make sure all equipments are working condition. If find any replaced defective equipment, make sure that it is immediately attended and immediately replaced. Calibrate your equipments like the monitoring equipments, your safety equipments every year. Maintain data of it. Maintain plant operation data either manually or electronically. It is nowadays very digital. Maintenance is very easily possible. Make sure that you have an emergency response plan in place. Do the mock drills regularly so that your people are trained and they know how to access those things required. Perform plant evaluation. This is one of the very key factors that we do not follow. We build up the plant and then we forgot it. We expect the plants to run for life. I have a customer who has the compressors installed in his plant in 1965 and still he is using. So I said, he was asking me, Anandji, what should I do? Should I service those compressors? I said, throw them and buy new one. So his question was very genuine. He said that I called the compressor manufacturer and he is giving me the new design of the compressor. So I am a bit very confused whether I should go for the new design. My 1965 compressors which are installed by my father are still working. So do your plant evaluations, change as per the technology when it is required, and select adaptable technology. It is very important you have a correct and adaptable technology. Do not go for buying a thing because of the technology. Like my partner bought the Mercedes because that was a thing to buy a Mercedes in 2004. And then we spent 2.5 lakh rupees in buying new tires and suspensions in 1.5 years. So buy what is important for you, why it is good for your plant. In many seafood plants, people put up very big screw compressors. And later on, they don't have that kind of load to process 365 days. So what happens is that the screw compressor is operating at lower capacity. So the expert comes in and says that, oh, you are operating plant at compressor at 70%. So you put a VFD. So your VFD will give you better efficiency. So he has to buy a new VFD. So capital cost is added. Instead of that, you buy the two compressors with 70% and 30% capacity or 60% and 40% capacity, and then you run as you require. That any switching of the compressor gives you the most energy efficient solution. So like I was stating, these two things actually, sustainability and energy efficiency, get mixed up. So what are the best practices of having a energy efficiency in a refrigeration plant? Reduce the installation and maintenance cost, go for lower capex and then low for the opex. Always try to keep increasing the efficiency. What is the most important thing which many times get forget is the ensure the food safety or the food quality. Do not compromise your refrigeration energy efficiency or run plant at higher temperature and compromise your product. Ramdas sir can tell us what happens is if ice cream is instead of -20, it goes to -15 storage temperature. So do not compromise food safety. Make sure, see, the main objective of refrigeration plant is to give us the temperature we need. All other aspects, energy savings, everything comes later on. So make sure that you follow these food safety. Whatever the food regulations are there, the requirements are there, the recommended temperatures. Like you have an apple, you need 95% RH, 4 degree, 2 degree temperature. Make sure that that is followed. After that only you implement the energy efficiency. Many times people talk about energy efficiency by switching off the fans in the ECU. So in a cold storage, when you switch off the fans of the ECU, your temperature delta or difference in temperature at the top and bottom increases very heavily. So your product may get damaged. So do not compromise product life, product quality by looking at the temperatures. As I told you, go for natural refrigerants, climate friendly refrigerant, and mostly energy efficient refrigerants. Don't just jump for the technologies. So typically when we are looking at an ammonia refrigeration plant, what we should do, we should have a lowest condensing pressure. Pranav talked about some automation into condenser. There are different ways of having automation. You control the fan speed, you control the in northern region I have seen people switch off the water supplies into the winter. Very good thing. They don't, because if your ambient temperature is plus 10 degree, why you need water? You can run the same plants with the air. So it's called hybrid condensers are being used there. So make sure, or like I said, you can have multiple condensers and simply switch off one condenser. Switching off device gives you maximum energy efficiency. Then look for the suction pressure temperature. You operate at highest suction pressure possible. Of course, raise your intermediate temperature pressure so that you are operating system at most optimized level. Lowest discharge and highest condensing gives you maximum energy efficiency, because your refrigeration plant power is discharge power divided by discharge pressure divided by suction pressure is your work done by your compressor. So you make sure that you have a lesser ratio, you have a better efficient system. Not popular in India, but in particularly in US, people used to use a lot of instead of mechanical pumps, they used to have the discharge gas to pressurize the gas to get through that. So don't do that, go with the ammonia pumps. Earlier ammonia pumps were very costly, so that was why it is done. Now it is available in India, so of course go for those pumps. Recover as much as it possible. I think we had a lot of discussion about heat pump, excellent discussion. So that's a good option available for you. You make sure that you have a correct system available, recover heat. There are other ways of recovering heat also. And then high efficiency motors, go for IE3, IE4 motors, VFDs when it's required. Make sure you have a proper defrosting systems, demand defrosting systems. Make sure your plants are automated and totally does not depend on the operator. And of course have a preventive maintenance rather than the maintenance after failure. So these all things helps you to get your system running correctly. I'll just go quickly through my observations. What happens is, or what is typically happens continuously in India. What are the observations? You always find high discharge pressure. Compressor pressure should be 12.5 or 13 kg and you find 15, 16 kg pressure. So as you have a higher pressure, you have more wear and tear of compressor, condenser scaling. Then you have, of course, the lesser life of the oil replacement cost is high, and you have these compressor maintenance issues. This can happen because of the scaling in the condenser or non-condensable gases in the plant. Secondly is low suction pressure. So it can be due to less quantity of refrigerant. People don't want to charge the refrigerant. There is a water in refrigerant. Plant design is not correct. Or systems controls are bypassed. This all leads to low suction pressure. There is a frost formation on the evaporator. The defrost system is not correct, or the proper defrost system is not being implemented. Sometimes long defrost times are used because of the water is being used as a refrigerant, which is very precious and costly nowadays. There is electricity. Many evaporator manufacturers talk about the electrical defrosting because for them giving hot gas defrosting means their coil has to be operated at higher temperature pressure. But electrical defrosting is very costly. My personal experience is that in some of the cases, the power fan of the evaporator fan power is less than the electrical heating cost. So go for hot gas defrosting. Make sure that you have a proper defrosting in place. Older plants do not have the automation. So make sure you have automatic automation in place. Automation, do not bypass it or do not use the incorrect automation. It means do not use the automation for the sake of automation. You understand your system, your operating condition, and make sure that you have it in place. So this is a typical graph about the scaling formation of condenser and how much you lose the energy. We talk about 2 mm thickness and you can lose as good as 30% of your energy in condenser. It is because heat transfer reduces. So what are the requirements? Maintain water chemistry, schedule routine maintenance, and make sure that it is clearly clean. You don't have to replace the condensers every time. Then you have, so what are the requirements? Make sure that your water quality is properly maintained. Considering time constraint, I will not read those slides, but you can take a photo or whatever it is. I'll share the presentation with Kailas and you can put it online. The quality, alkaline level, pH level of the water used condenser must be maintained properly. Keep on continuous monitoring it. Microbiological things maintained, corrosion rate you mentioned, and you make sure all the data is being recorded and properly maintained. Make sure that there is a proper blow down of the water is there, because once the water circulates from the condenser, there is a possibility of increasing the TDS, suspended solids get accumulated. So make sure that you are bleeding that water and bringing in the fresh water. So all these things are continuously required. These are some of the photographs of how the condenser clots. If you use the proper anti-scalant chemicals, it can be cleaned again. You don't need to replace the condensers. These are some of the examples shared with me. Defrosting, instead of going air defrosting, water defrosting, or the electrical defrosting, go for a hot gas defrosting. Hot gas defrosting is the most easiest, safest way of doing it. Hot gas is freely available in your plant. You make sure that defrost system is automatic. It should not be manual, and then you have a proper system. As I told you, air increases your electricity cost, decreases depletion capacity. So make sure that your air is being removed continuously. Preferably go for the automatic purging systems, and you save a lot of into the purging, because when you do the manual purging, then when you don't do the purging, there is ammonia is going to, the air is going to remain in force. If you are doing it once in a month, or 1 month, you are going to carry the air in your plant, and it is going to cost you. So make sure that you follow the proper purging, the correct system is being installed. This is a typical example from an ice cream plant. They were running plant at 16 kg. And after installing the air purger, their pressure dropped down to 12 kg. The net benefit or the payback period of purger was less than 1 year. And secondly, the advantage is that other than that, they got more refrigeration capacity from the same compressor, because you are operating at the lower discharge pressure. So whether you use it in the freezing plant, use it in potato cold storage plant, there is always heavy saving onto the refrigeration electricity. There is a saving onto your compressor parts maintenance. Same thing, ammonia water. Water has got a great affinity with ammonia, and as the ammonia water mixes, the pressure, basically suction pressure has to go down to get the same temperature, or at the same pressure you get higher temperature. So you lose your product and quality. The corrosions are there. There are pressure drops, sludges formations, oil damage, compressor bearing damage. All these things happen when there is a amount of water in ammonia your plant. You can simply see here some of the cost of water can be very high, and you have to make sure that you are properly then last part, just give me 2 minutes, Kailas. It will be importance of automation. Make sure that your plant is being automated, properly run, and make sure it is optimized. It means don't spend heavily on the automation. Don't buy high fancy automation systems which will cost you heavily, and then later on you cannot maintain it. Make sure that your automation systems gives you data is being recorded and available on your computer or on your mobile. You can see anywhere in the world, share with your customer. You can go for a PLC SCADA based automation for a bigger plant, so you have a more optimized control. You can control number of compressors running, defrosting, everything can be controlled. You can go for an individual compressor control, individual plant control, and then have a lesser payback period for the same. And it can be less than 3 months if you go for an individual thing. If you go for a SCADA PLC system, your payback period would be less than 2 years. So make sure that you select the proper automation system depending on your plant location, availability of your people for you, and of course the easy serviceability of it. So typical plant is just shown here, all the automation controls, and then you can do a better one. So what's the final thing is select environment friendly, energy efficient refrigerant. Equipments, components must be standard quality certified from the authorities. Try to look for Make in India, considering our political situations, the war conditions. Do not depend on the other countries for it. Product quality is very important. Use correct quality, certified quality products. Do not use substandard materials. Follow the standards available. Maintain plant properly at rated conditions, design conditions. Save energy by optimizing plant performance, and that can be done better with the automation. And of course, make a lot of money by having a correct plant, sustainable plant and efficient plant. Thank you all.